Hello, good morning to all the students. Okay, anybody here? Celia, morning. Okay, you can listen me, then you just tap there, yes, then I can continue my lesson. Okay, Celia, can listen me or not? Okay, we just only Celia. How about your sejarah teacher? Still going on? Okay. Okay, so I just to continue our lesson. There's a gas law, the last part for the gas law. Okay, before that, we learn about the Boyle's law. Then we learn about the Child's law. Okay, and today we need to introduce the last one. Okay, the last one, they're still in 4.4. The name, we call it as a gay. Okay, we got it as a Gay-Lussac law. Okay, Gay-Lussac law. Okay, but before that, we learned that we're using the pressure law. Okay, but this now the syllabus they changed already. They want to using the scientist name, so they're using the name for the scientist lah. There's a Gay-Lussac, so they add the law at the bottom. Okay, so this one law they're talking about the pressure and also temperature. So what should be constant? The volume should be constant. Okay, we all talking just only for the gas. Okay, we just start only. Okay, a few classes course I got PTBR. Okay, never mind, Tivesh. You can recall back. You can recall back to see the YouTube. Okay, so for this one, we just continue for the last part for the 4.4. There's a gas law. So we all talking the object now is a gas. Okay, let's see the relationship. So this one relationship is related with the pressure and also temperature of the gas. Okay, for this one situation, what should be constant? The constant is the temperature. The constant must be the volume constant. Okay, the container volume must be constant. Okay, now we continue to see this part. Okay, the driver drive the car, touched the tire after the journey and found that the tire is hotter than the before journey. So that means before that, the driver, they go to check the tire. Okay, after the journey, they find that the tire become hot. Okay, become hot. So from here, they want to check. Okay, they want to check the A of the tire before and after for the gas pressure. So from here, the first round, they go to check before the journey. You can see here. Okay, the reading from here, they show about 200 lah. Okay, 200. Then after that, after the journey, they find it more a bit. Okay, more than 200. So this was one of the question they will ask. Why become like this? After the long journey, then you find it, the gas pressure changes. Okay, after long journey, you find sure become hot lah. The tire become hot. So this one we can say it, the temperature increasing. Okay, after you move for long journey. Then after that, the pressure actually we cannot see what. So we need to test it. So when we test, we also find it, the gas pressure in the tire also increase. Okay, so from here we need to find out this one relationship. Is it directly proportional or just increase linearly? Okay, so from here, this one is a third experiment you need to write inside your exercise book. They want the experiment book. Okay, so this one experiment 4.6. Okay, from your textbook, you need to copy. So I repeat again, you need to copy. So you don't need to ask me again, need to copy or not. So for the experiment chapter 4, you need to copy 4.4. Okay, first one is the inference. So the inference is the temperature of the gas that will influence the pressure of the gas. So that means the temperature increasing, they will affect the gas pressure. Okay, hypothesis, the higher the temperature means we control temperature. Temperature sure is a manipulate variable, then the higher the gas pressure. So from here, we determine the relationship between the temperature and also pressure. Okay, which one should be fixed? The mass. The mass of the gas must fix and also the volume must be fixed. Okay, this one is a constant variable. Okay, now we see the variable. Manipulate variable, that's a temperature. Responding variable is a pressure. And the last one, constant variable, there's a volume and also the mass. Okay, or it's a gas. Temperature of the gas, pressure of the gas, and also the volume and mass also for the gas. Okay, so from here now we're going to see the apparatus. Okay, apparatus we're using the round bottom. Okay, round bottom fast. After that we got large beaker. Large beaker you want to put the water because you need to heat the water. Okay, thermometer, pressure gauge, Bunsen burner. Okay, heating must together three things: Bunsen burner, wire gauge, and thermostat. Okay, after that you got stirrer. Stirrer, you want to make sure the water is heating in even temperature. Retort stand and also wooden block. Okay, let's see the diagram. Okay, the diagram just like this. You want to put ice, you don't want to put ice, is up to you. If you put ice, means you can lower the temperature of the water. So you can start with the temperature lower. Okay, if you're never using the ice, that means your temperature must start over 30. Okay, that one is a room temperature. So from here, you can see this part. This one is a button gauge. They're using to measure the pressure. Okay, when it's just moving, the needle just moving, then you just read. Okay, the tube, they will join with the flask. Then the flask inside should be empty. That's a A. Okay, the flask is A. Then after that, the big beaker, they put in the water. Okay, the water fill in the into the beaker. Then you got stirrer, then you got thermometer. Then this one must be together. Bunsen burner, tripod stand, and also the wire gauge. Okay, let's see the procedure. Okay, heat the water slowly and stir it continuously until the temperature of the water reach 30 degrees Celsius. So that means you need to start with the 30 degrees Celsius. So you take the reading of the A pressure. So after 30 from the thermometer, then you go to read the reading from the button gauge. Okay, now the pressure P inside the flask, recording the reading in the table form. Repeat the step 2 and 3. Now you need to increase the temperature of the water until 40, 50, 60, 70, until 80. So we assume the water temperature same like the gas temperature. It both is a thermal equilibrium. Okay, so from here we just record the reading of all the different temperature and also different of the A pressure. Okay, after procedure, you draw the diagram. Remember, must draw the diagram. Okay, so the arrangement, we start with the inference, hypothesis, then we start with the aim. Okay, after the aim, there should be the variable. After the variable, they go through to the apparatus. You need to mention all the apparatus, then you need to draw. After draw, procedure. Okay, then after procedure, sure is a result. Okay, let's see the result here. Result we must write in table form. In table form. Okay, one column we just write is a MV, manipulate variable, and another column should be the responding variable. So we control the temperature. We start with 30, so we write 30 until 80. So this one is an example reading. Okay, example reading for the pressure. So we find it. When 30, there's 111 kilopascal. We count by kilopascal. Until 80, they up until 130 kilopascal. So that means the A pressure, they're increasing with the temperature. Okay, so from here, we need to analyzing this result. Okay, analyzing, normally we need to plot the graph. You're going to do the analyzing. After you plot the graph, you're talking about the graph is what relationship. So this one, we call it as a analyzing. So we see the analyzing. First one, a graph P against data. Okay, you need to draw. Okay. Number 2, extrapolated. After you draw, you need to extend the line until the P equals 0 kilopascal. So that means when you draw normal graph, you cannot get that's a directly proportional. Okay, then they want you to extrapolate it. So they want you to extend the line until you cut to the x-axis. That means there's a 0 kilopascal. So you need to determine the temperature when there's a 0 kilopascal. So they're just like the Charles law graph. Okay, just like exactly the same. So we're going to show this one is a graph, normal graph we go to plot. Okay, there's a kilopascal versus degree Celsius. So from here, we cannot get directly proportional. This one, we just can say there's an increase linearly. So from here, the graph show P increase linearly with the data. Okay, so that's why they want you to extrapolate it. So that means your graph, you must draw at the middle. You draw at the middle, that means later you got space to go to extend. Okay, so from here, we're going to see conclusion for this one graph. Conclusion, we just say the hypothesis is accepted. So when the temperature just increase, the pressure also increase. Okay, so from here, we just say the pressure of the A increases when the temperature of the A also increase. So from here, we just say hypothesis is accepted. So conclusions, normally we just copy from the hypothesis. Then you add one more sentence, the hypothesis is accepted. Okay, so from here, this one is an example diagram to show you lah. So you can see the piston, the volume is the same. So before that, if you never heat, the pressure is number 2. When I just go to heat, you can see the molecule must go faster. When the molecule just go faster, understood, kinetic energy increase. When the kinetic energy increase, they will move faster, is it? When they move faster, they will hit. Okay, hit where? They will hit each other. Okay, then the piston volume you fix already, you do changes. So then no space, there's no space to go. They only the small space. Finally, they will hit to each other, and also the surrounding, they got a container, they will hit. Okay, so Silang got answer question. The graph that we need to do extrapolated, actually you no need to do lah. I don't want you to do because you need to you never cross perfect. You cannot get exactly -273. Okay, I just want to let you to know. Okay, when you plot the graph, you can get like this only. Okay, so you can plot this one graph, the normal graph only, then you get increased linearly. So you want to try, you can try by yourself to cut it. Okay, to cut it, because your graph paper, the scale is very small. Okay, the scale is very small. When you want to plot until you cut to the -273, the scale you cannot read already. Okay, unless you make the scale is very, very small, then you can read it. Okay, you just plot normal graph. No need to plot until extrapolated. Okay, so from here, T. West got say about the Boyle's law is pressure and volume. Charles' law is a volume and temperature. And the Gay law is pressure and temperature. Yeah, correct. Okay, yeah, correct. So we go through to the continuous to extrapolated. We see the graph. Okay, this one is a graph extrapolated. So that means if you want to draw the graph extrapolated, your scale for the x-axis, you must draw until 200 something. So that means this one graph, okay, for the right-hand side, you need to draw very, very small because the scale you cannot separate one. Okay, so from here, I just not encourage you go to draw lah. I just want to inform you. Okay, inform you the result if we draw extrapolated graph. So that means now this one P against data again. If you do the extrapolated, you pull until they can touch to the to the x-axis. There's a 0 kilopascal. Suppose the reading should be -273. That one is an absolute 0. Absolute 0. Because that one is a 0 Kelvin. Okay, so from here they say at 0 degrees Celsius, gas molecules are still moving. Okay, the gas molecule, they're still moving, and the gas has pressure. They still got pressure, although there's a 0 degrees Celsius. Okay, after that, the gas pressure will become 0 when this one situation, when -273. Okay, the gas will become 0 when there's a -273 degrees Celsius. So the graph P against the T, the gas is straight line through the origin. When you change, the T become Kelvin. Okay, when you change become Kelvin, so that means when you plot the graph, they should be directly proportional. Okay, understand? So the same like the Charles law, exactly same like the Charles law, means we need to using the calculation. When you do the calculation, the temperature, you must change to the absolute temperature. Okay, using the unit for Kelvin. After that, you change it become degrees Celsius. Okay, so this one is the Gay law. Okay, so from here, the gas pressure now is directly proportional to the absolute temperature. Okay, after you change become Kelvin. Okay, so this one you must very, very clear when you plot the graph. Is it versus Kelvin or versus degree Celsius? Then you must see how they go to plot. Okay, if they versus degree Celsius, sure increase linearly. If they versus Kelvin, sure is pass through origin. Okay, so if they pass through the origin, we can write the equation. P directly proportional with the T. So this one is a symbol when you just write directly proportional. Okay, this one's one of the short video to show you the relationship for the temperature and also the pressure. Okay, we're going to watch. Okay, when it just Kelvin with directly proportional, so this one is a gas molecule. Okay, when it just heat, okay, then you see what happened. Okay, when it just heat the pressure, burden gauge, okay, they will show the reading, they're up. Okay, container, the volume is a fix. Okay, you can see they move faster. After that, they collide with the container. So that's why they will increase the pressure. Okay, then we go through to the cooling. Okay, when it just cooling, you can find it, the pressure drop already. Okay, because the kinetic energy drop. Okay, they move become slowly. When they just move become slowly, that means the collision between the molecule and also container, they will less. When it just less, pressure drop. Okay. Okay, then we go through to the next part. Okay, for the Gay-Lussac law, okay, what they're talking about. Okay, they just give the definition is the pressure is directly proportional. Excuse me. Okay, the pressure is directly proportional to the absolute temperature. Remember, it's absolute, not only temperature. Then you need to mention about the fixed mass and also constant volume. Okay, let's see the formula. Just now we proved already. P directly proportional with the absolute temperature. Okay, if I just take out the directly proportional, the symbol, actually you can write K equal K. K means gradient. If you plot the graph, P versus T, you write the straight line, is it? Then you find the gradient, actually there's a constant number. That one constant number, we're using the K to represent. Excuse me. So from here, the K, then there's a constant value. P is what? P is a pressure. T is a absolute temperature. Then remember the unit is Kelvin. Okay, we're using Kelvin. Okay, so from here, if I plot the graph, okay, for the first situations, okay, the container, first situation, I go to heat. Okay, I think this one symbol is wrong. Not V, we're using T, not V. V is a volume, is it? So this one should be T1 and T2. So when I just heat around, example, 30 degrees Celsius, when I just heat 30 degrees Celsius, I get P1. So I continue to heat, same container, I continue to heat, become T2. T2 is what? 50 degrees Celsius. Then we see what happened for the P2. P2 will be increasing. Okay, just like this. So the graph, when you just plot in Kelvin, there's a directly proportional. So every point on the line, okay, you find the gradient should be the same. So that one, the gradient is a constant value. Okay, if the whole situation you never change lah. Okay, unless you say you add the mass for the gas are different. If you at the middle, when you just hit at the middle, you open the lid, you let the air to come in. That one is a different. Okay, we're talking is a whole thing is a constant. So we do the experiment twice. So that means you can get the result for the gradient should be the same. Okay, now we see the condition. Condition for the first one for the gas, we get it P1 over T1, there's a K. Gradient is a K. Okay, now I continue to do it. Second condition to heat the same gas. So we find it there's a P2 over T2 also is a K. So that means I can make the relationship for these two formula. I can combine already. So when I just combine, they will become P1 over T1 equal P2 over T2. Okay, so which one should be constant? Volume constant. If follow this one's tips, so we can find it. Remember the triangle? Before that we show already. There's a PV over T. So now for the Gay's law, there's a volume constant. Volume constant, we just go to close the volume. So now your formula become P over T. There's a one constant value. Okay, so the formula for the Gay-Lussac law, there's a volume constant. Then the formula is a P1 over T1 equal P2 over T2. Remember, T must using absolute temperature. So that means you need to plus 273 when do calculations. Okay, so from here you can see the this one important, the formula for the Gay's law. Okay, then we're going to see this one example. They want to show about the formula. Okay, both one is heated, one is no is heated, that the temperature is low, another temperature is high. So when they just do the calculation, actually both also is the same gradient. So from here we can create the formula P1 over T1 equal P2 sorry, Celia, we cannot change the formula or V1. Sorry, not V1 is a T1. Okay, just now the graph a little bit problem. So you're using T1 and not V1. If you want to change P1 over P2 over T equal T1 over T2 is okay. Okay, it's okay. So don't using V1. V1 is a volume. T1. Okay, so P1 over P2 equal T1 over T2 is correct. Okay, you want to using both side is a P, another side is a T, that's okay. Okay, so this one formula actually you can change this lah. Okay, now you can see this part. Okay, this one is a constant volume. Volume is a constant. So you can see this one is a P1, pressure in the piston, never heated. They never heat. So another situation, you can see they got heat. They provide the heat. So you can see the molecule, they move faster already. They move very fast already. So they say when a fixed mass of being heated at a constant volume, so now when the temperature of the gas just increase, the average kinetic energy of its molecule increase. Okay, so temperature is related with the kinetic energy. When temperature is high, kinetic energy must be high. So, and the molecule will move with very higher velocity. Okay, now number 3, as the volume of the gas cannot change. Okay, the volume already fixed. So that means the rate of collision of the gas molecule with the wall of the container increase. When I just mentioned heating with the wall container, understood related with the pressure. Okay, so from here, finally, we can just mention force per unit area on the wall of the container also increase. So that means the molecule got weight, is it? Got mass. Mass got weight. Weight is a force. So when the force just acting to the unit of area, the area from where? Container. Container is the area. So when it just hitting per unit area on the wall of the container, then they will increase. So that means the pressure increase lah. Finally, the last one, gas pressure increase. So this one is what situation we need to explain like this. When the question asking about kinetic theory, okay, the molecule kinetic theory in the Gay's law. So you need to explain like this. When the temperature just heat, then kinetic energy must be increased. Then the velocity of the molecule increase. Then you must talking about the collision with the wall container. Okay, force per unit area of the wall of container increase. Finally, pressure increase. So this one is how we go to explain by using the movement of the molecule. Okay, so now we go through to the last one to show you the fixed mass of the hidden constant volume. So the volume of the piston is a constant. So when starting, they never heat, you find they move in low velocity. When the just temperature increase, they're moving very fast. When they're just moving very fast, that means the heating should be more frequently. Okay, more frequently, that means force per unit area of the container, they will be increasing. Then they increase the pressure. Okay. Okay, so this one just one of the short of the law. There's a Gay's law. So what you need to do, you need to copy the experiment report. Okay, experiment report for this one, the last one, gas law. Okay, there's a Gay-Lussac law. Okay, now we need to prepare calculator to do some of the question about the Gay's law. Okay, student, you ready? So I just start the question. Remember, absolute temperature. Okay, the gas in a closed steel cylinder, okay, has a pressure of the 180 kilopascal. So this one is the first one, P1. At a temperature 25 degrees Celsius. So this one is a T1, temperature 1. Okay, what is the gas pressure when the cylinder is heated to a temperature 52? So 52 is a T2. So what they want to find is a P2. Okay, pressure 2. So from here you can show about the important temperature must convert to absolute temperature. Okay, so this one is an important things to remind you. Okay, the next important thing we need to write out all the informations. This one also is important. So you see the P1 is 180 kilopascal. P2 we don't know. Okay, we just put question mark. So T1 you straightforward go to convert. Okay, don't waste already. Oh, so fast. T-Wash give me the answer already. Okay, so we go to explain first. 25 plus 273 become 298. Then T2 is a 52 plus 273. Okay, 325 Kelvin. Then we're using the formula. Okay, you want to convert P1 over P2 also can. Okay, so from here, we go to show, put in all the info. 180 over T1 is how many? 298. Okay, then P2 we do know. Then T2 there's a 325 Kelvin. And the last one, okay, P2, the last one. How come got degree Celsius, Celia? Okay, this one is a P2, pressure. Unit is wrong. Okay, P2 must be follow the question. The question using kilopascal, then we using kilopascal. Okay, don't forget your unit. Okay, must write the unit. So the answer is 196.3 kilopascal. Okay, kilopascal. Okay, correct. That's a kilopascal. Okay, must use the units. Okay, the unit you just follow the question. You don't need to change already. Okay, then we go through to the next question. Okay, the next question. Okay, important again, absolute temperature. Initial pressure of and also the temperature of the air in the tire of the car, 210 kilopascal and 25. So this one is a first case. That means first case for the pressure one and temperature one. Okay, after the journey, after journey means the second case lah. After the journey, the air pressure in the tire become 240. So this one is a pressure 2. Okay, calculate the temperature of air in the tire. Then I want degrees Celsius. So that means you find the answer in T2. That's in Kelvin. You help me to convert, become degrees Celsius. Okay, so from here we show the info. Okay, this one is an info. P1 is a 210 kilopascal. P2 is a 240. Then the T1, you please convert to absolute temperature. You plus 273 become 298 Kelvin. Then T2 we do know. After you find the T2 in Kelvin, you convert become degrees Celsius. Okay, so from here, I need your student to give me the answer. Okay, so Sabrina, give me 67.57 degrees Celsius. Okay, we go to chat. Okay, P1 over T1 equal P2 over T2. So we just put in all the info. Okay, yeah, 3 students also get it. Siliang, Sabrina, and Tivesh. Okay, now we go to put in all the info, then we find T2. Okay, T2, suppose we get it is a 340.6 Kelvin. Okay, this one not the answer. Still not the answer. Okay, then I need to minus. I need to minus 273 to convert back, become degrees Celsius. So the final answer 67.6. Okay, 0.6, not 0.75, is it? Okay, Divesh, you help to check the behind the decimal point. Suppose it's a 67.57. Okay, after that I make it round number 67.6 degrees Celsius. Okay, so this one is the answer. So from here, I think there's a no problem. For the student, you find pressure also can, you find temperature also can. The formula is still the same, but important, you need to know this one is a Gay's law. Okay, because three law is mixed, is it? Later, when they just mix together, you must very clear for the question what they want to ask. Okay, number 3. Now you see a gas in a container with the constant volume. When you just see the word constant volume understood, the one is a Gay's law. Okay, that has a pressure 200,000 Pascal. Okay, at the temperature 30. So this one is a set number 1. Okay, then they ask you what is the pressure of the gas if the temperature is increased to 60. Okay, case number 2, the temperature now becomes 60. So they ask you what is the pressure for the case number 2. So we just write the info. Okay, the first one, then 200 kilopascal. You can straightforward to write the 200 kilopascal because this one is a 200,000. So we change the 1,000 become kilo. Then the P2, we don't know how many kilopascal. After that, T1, I convert become Kelvin. That's a 303. T2, I also convert become 333 Kelvin. Okay, so from here, you need to find for me the answer for P2 is how many. Okay, T-Vesh straightforward, give me. Okay, T-Vesh, can you give me the unit or not? Unit, okay? Must have the unit. Okay, Siliang give me 2.198 times 10 power of 5 Pascal. Okay, correct. Okay, if you want to change become Pascal, it's okay. You want to change become kilo Pascal, also can. Okay, so from here, I just write the info. Finish ready, then we show about the formula. Okay, then 200 over 3033. Then after that, P2 over Kelvin 2. Okay, then we put in, we want to find P2, is it? So P2, if I using kilopascal, my answer kilo lah. Okay, you want to convert become Pascal, also can. So from here, we go to show, my answer is a 219.8 kilopascal. Sorry, kilopascal sudah hilang. Okay, not K, kilopascal. Okay, I go to write Pascal first. Okay, kilopascal. P is capital, kilopascal. Okay, so this one should be the answer, kilopascal. If you want to write the answer like Siliang also can, 2.198 times 10 power of 5, then Pascal. Okay, that's correct. Okay, 219.8, Su Hui also correct. Cha Song Ching also correct. Okay, so this one should be the answer. Then we continue to the next question. Number 4. Okay, number 4. Number 4 is a cylinder of the oxygen. Okay, you see, the oxygen is 27 degrees Celsius, has the pressure. Okay, so this one is the case number 1. What is the temperature of the oxygen if the cylinder is cool and also the new pressure become this one? Okay, they want temperature, but normally the temperature we find in Kelvin, is it? But the answer is normally you need to change become Celsius. Okay, that one is a final answer. Okay, because they see the first one, the T1, they give you degrees Celsius. So the T2, you also must be convert become degrees Celsius. So this one should be the info. Okay, P1, P2. Then after that, they ask you about the T2. T1, I go to convert first. 27 plus 273. So I get it 300 Kelvin. So now I just want the final answer for T2. And also I want in Celsius. Okay, I want in degrees Celsius. Okay, Sirang so fast, they give me 0 degrees Celsius. Okay, if 0 degrees Celsius mean later you get the Kelvin must be 273 lah. Agree or not? Okay, Sabrina also same. Give me 0 degrees Celsius. Okay, now we go to check. Okay, I put in P1 is how many? Over T1. So this one is a P2 over T2. So from here, I do the calculations. So finally, I get T2 exactly 273 Kelvin. Okay, but now I want to convert become degrees Celsius. So I need to minus. Okay, I using 273 Kelvin. They go to minus. Okay, absolute. So after that, I change back become degrees Celsius. I get it. 0 degree Celsius. Okay, so this one is another question. Okay, not wrong. Don't think, oh, how come become 0 is okay one? This one answer is okay one. Okay, that means you make the temperature for now the oxygen gas is the freezing temperature, 0 degree Celsius. Okay, number 5. For the fixed mass is a fixed gas in an enclosed metal container. Enclosed, that means they close already, don't have any air can come in. Has a pressure, okay, pressure P1. Okay, if the gas is heated, now the gas is heat from 27 heat until 87. So that means the first one is 27. Then the second one become 87. Now you need to calculate the final pressure. So that means you need to find is a P2. Okay, P2. Okay, let's see the info. P1 already got, P2 we do know. T1 and T2, please convert to the Kelvin. Okay, convert to absolute temperature. So final answer you need to find is a P2. Okay, P2 in Pascal. Okay, we follow the question in Pascal. You want to change become kilo is okay. Depends for yours. Okay, see then get 300 kilopascal. Okay, so we go and check. Is it 300 kilopascal? Okay, the formula is the same. So we put in all the info P1 over T1. Then after that, P2 we don't know. Then this one is a T2 lah. Okay, so from here we continue to do the calculations. Put in all the info. Okay, last P2 is 3 times 10 power of 5 Pascal. Same like 300 kilopascal. Okay, it's the same. Okay, you want to put in Pascal, you want to put in kilopascal also can. Okay, so I think every student also okay, is it? There's no problem for this one calculations. Okay, just a simple only. Important you remember the formula. Okay, remember the formula. Okay, so we continue to the number 6. Okay, number 6. The pressure of the some oxygen at 1.5 atmospheric. Okay, this one they never using Pascal. They're using the unit for the pressure is atmospheric. Atmospheric. Okay, it's to be increased to 27 atmospheric. So this one is a P1. Okay, P1. Another one should be the P2. Okay, if the initial temperature is a 12 degrees Celsius, what is the final temperature of the oxygen? So the info, we're using ATM, atmospheric. P1 is 1.5. P2 is 2.7. Okay, T1, please convert to become the absolute. There's a 285 Kelvin. Then T2, we do know. Okay, T2, you find the answer also must convert become degrees Celsius. Okay, so that's your turn. How many to change become degrees Celsius? Okay, see then already get 240 degrees Celsius. Okay, now we go to show. Formula is the same. Okay, put in the info. You don't care about the unit because the unit later you also can be cut. So we just write 1.5. Then over T1 is 285. Then the P2. Okay, P2 is 2.7. Then the T2 we don't know. Okay, so we do the calculation. We find the answer in Kelvin first. Okay. Lim Si Liang just like the thunder. Lim Si Liang, why you become thunder already? Okay, there's a light speed. Okay, Lim Si Liang is a light speed. Okay, so from here you can see the T2 I get it is a 513 Kelvin. Okay, 513 Kelvin. So from here, you need to convert 513 becomes Celsius. So we just minus lah, using 513 minus 273. So final answer is 240 degrees Celsius. Okay, so this one should be the answer. I think there's a no problem. Okay, so from here, I think this one should be the last one. Okay. Oh, we still got 7. Okay, 7. Okay, now T-Wesh. T-Wesh, you faster. Faster than Xiliang. Okay, a motorist. Now they blow up his motorcycle tire. The pressure is 2.7 times 10 power 5 Pascal. In the cool morning, when the temperature is 15. So what is the pressure for the tire in the hot day? The temperature becomes 37 degrees Celsius. Okay, so from here we need to show lah, info. Okay, this one is an info. So from here, P1 they provided, P2 we don't know. Okay, after that, the T1, please convert to absolute. So 288. Okay, T2 we also convert to the absolute. That's become 210 Kelvin. So you find for me what is the P2. Okay, P2 Wow, thunder already. Okay, T-Wesh. 3.123 times 10 to power of 5. Okay. Okay, now we go and check. Okay, formula is the same. Put in all the info. Then after that, how come Sabrina got different answer already? Okay. So this one is Sivesh give me 3.1323 power of 5. Okay, Sabrina give me is a 290. Okay, we go to check. Okay, P2, put in all the info. Put in all the info. Then we find the P2. P2 must in Pascal. You want kilo also can. So from here, I get it 2.91. Yeah, correct. Okay, for the Sabrina, that's a correct. Sivesh, thunder so fast already. Now you thunder wrong thing. So from here, the answer is, follow the answer from there, Xiliang and Sabrina, that's a correct. Okay, you can write 2.91. You can say 2.90.625 kilopascal. Okay, in Pascal also can, in kilopascal also can. Okay, so from here, please be careful. Don't think fast is very good. Fast not exactly correct. Okay, so here must be careful when you do the calculations. Okay, so from here, I think this one should be the last lah. So this one is a conclusion I want to show you about the gas law. We got Boyle's law. Boyle's law, which one close? Boyle's law, we want to close about the temperature. So they become P1, V1 equal P2 to V2. Okay, number 2 is a Charles law. Charles law is a V and T. So you close the P. So become V1 over T1 equal V2 over T2. Remember, must using absolute temperature. Okay, and the last one, this one is the last time they call pressure law. Now they call Gay's law already. So Gay's law, which one constant? Volume is constant. So the formula is a P1 over T1 equal P2 over T2. Okay, also using absolute temperature. Okay, hopefully you understand about the gas law, about the tree of the law, and also different things become constant variable. Okay, so from here, we can see some of the example lah. For the Boyle's law, normally they're talking about the A bubble. Okay, A bubble in the deep sea and also surface of the sea. Okay, Charles law, they're talking about the hot air balloon. So that means the volume. When the temperature bigger, the volume will be expand. And the last one for the Gay's law, they're talking about the tire. Okay, the tire for the long journey, temperature increasing. How about the gas pressure? Okay, so this one is an example. Okay, so today lesson just until here only. So what you need to do is formative 4.4. Okay, formative 4.4, copy inside your exercise book and write the answer. And one more thing should be the Google form lah. Google form for today attendance. I already upload there. Xiliang, is it or not? Can you check, is it inside your Telegram that got the Google form? Okay, want to make sure got Google form or not. Okay, you go to check first. for your Telegram? Is it a Google Form? Oh, God. So Google Form sure got the code lah. Okay, help me to type the code lah. I'm going to see today is what code. Okay, today the code is a pressure. Capital letter, pressure, hashtag 88. Okay, we just write here. Pressure, capital letter, I just write for me, pressure, S-S-U-R-E. Okay, pressure, then you put hashtag. Okay, hashtag. Push the hashtag, then you put the number 88. Okay, thank you, Tivesh. Attend my class. So from here, I pin the answer already. Oh no, I pin the code already. The code is a pressure, then hashtag, then 88. Okay, so from here you need to write the answer there. Okay, so write the answer there. After that, you can get your today attendance. Thank you, Sabrina. Also, thank you, Divesh, to attend my class. Okay, for science 2, for science 3. So today the lesson should be finished. Complete the formative practice and also the Google Form. Google Form must do first. Okay, so today's lesson just until here. So thank you, everyone. So the next lesson should be chapter 5. Okay, everyone, bye. Thank you.